Okay. So you have any doubt in this part, in that differentiation? Okay, fine. So if it is clear, then we will move on to the next line. Okay. So after you are doing the differentiation a by p, you will get this expression. Okay. Here again, dA by dy you can write top with divided by twice rp. Okay. We have twice rp. Okay. Then minus, we have area, we have p square, and in place of r again we have written, in place of r is a by weighted perimeter. Okay. So this will be dp by dy, remain same. Okay. So this will be t by a again. Again that r is replaced by a by p, so this p will be cancelled out, and then this p and this square will be cancelled out. Okay. So this area is also cancelled out. So it will be 1 by twice p, 1 by twice p dp by dy. Okay. So what will be left out will be t by a, then t by twice rp minus that thing we have already seen. Okay. So after the twice a, we again multiplied by a by p. Okay. So this a will be cancelled out. So bring r. Okay. Bring r. This is as the expression. Okay. So this r by a is nothing but r by a. If you solve again, this is area by perimeter, and this is area. Okay. This area will be cancelled out. So ultimately, you will get 1 by p. Okay. So 2 is already there. So ultimately, you are going to get 1 by twice p. Then you add t by a plus t by twice a. You will get 3t by twice a. Okay. Minus r by twice a dp by dy. Okay. So here also we have twice a. So we bring it out here, and then it will be 3t minus r dp by dy. Okay. So this is our equation number 3. Now in both equation, our left hand side is same. That is d by dy log ek. Okay. In equation number 2, it was d by dy log ek is equal to n by twice y. N by twice y. Okay. That is our equation number 2. And this is our equation number 3. So in both the equation, the left hand side is same. That is why we can equate both the equation, and we can write n by twice y is equal to this. I can say this. Okay. From here, you can directly find out the n expression for hydraulic exponent, that is your capital N. This 2 and this 2 will be cancelled out. N is equal to y by a. Will go here, y by a, and this will be same as equation number this. Okay. It will be remain same. Kt minus r dp by dy. So this is the expression for N for hydraulic exponent for computation of uniform flow using Sage's equation. Sage's equation. Using Sage's equation. You can write this line after that equation 4, which is the general equation of hydraulic exponent in uniform flow with Sage's equation. So kindly go through the derivation, and if you have any doubts or any problem you face, we can discuss here. You kindly go through the derivation once and see you have understood or not. Okay, then I assume there is no doubts. Okay, then we move on to the next derivation using Manning's equation. Okay, see, before we move on to the next, what the equation we have derived, then depending on the shape of the channel, we are going to find out the cross sectional area, then R value. Okay, suppose here you can see that here again it is a trapezoidal channel. So this is the equation for area equation for trapezoidal channel. This is top width. Those things we have already discussed. Okay, this is the weighted perimeter. Then if you see in that expression we have dp by dy. Okay, that is differentiation of weighted perimeter with respect to y. So to calculate this value we have to differentiate p with respect to y. Okay, so we will get this expression for trapezoidal channel, and then we are going to apply for n. We are going to substitute all the expression of trapezoidal channel, and ultimately we will get a expression for n for trapezoidal channel. Okay, so similarly you can go for wide rectangular also, whereas you can get that n value is 3. Okay, for wide rectangular you can see for wide rectangular n value is 3. For rectangular channel you can see this expression. So this whatever we have derived, that is a general equation you can apply to any channel section. Okay, for triangular I think it's 5. Yes, for triangular it is n equal to 5. So those are the things you can directly find out by substituting in the general equation. Okay, so we will move on to the next derivation. That is same. See, both the derivation is similar. Only in velocity, in previous case we have using Say's equation, and here we are going to use Manning's equation. Okay, so you write case number 2 when Manning's equation is used. So again we will take the discharge equation, area into velocity. In place of velocity, we use Manning's equation, that is 1 by n r to the power 2 by 3 sb to the power half. Okay. Then again, we know k is equal to q by sb, nothing but your k. Okay. So this is our k equation. We will substitute that, put that equation number 1. Okay. So then you can write this expression. You can write here also that same line that you have written for this equation, that our area and hydraulic mean depth is a function of y. So it's a relationship between, you can write this one, a square is equal to c dash y to the power n. Okay, so here again you can write c dash is nothing but your constant and n is nothing but your hydraulic exponent. So again, we will take first logarithm in both side. See here it is written ln. So you people all know ln is nothing but your log e. Okay? So you can write log e or you can write ln. Okay? It's up to you. So there will twice log ln. So one step here it is skipped. Okay. This thing is similar to your first case. Okay. Log e. Okay. We have twice here. Then log e is c dash plus n log ey. Okay. Then you differentiate. Okay. We'll write here again. C dash plus n log ey. Okay. Now we differentiate. So 2 is will be there. Differentiating both the side. Differentiating equation above equation with respect to y. With respect to y. Okay. So dy dy log a. This thing will be similar to your first one. Okay. Then differentiating this will be constant 0. Then again it will be n by y. Okay. So here you can again you can write here dy dy log ek is equal to n by twice y. Okay. This is our equation number 2. Okay. So this is our equation number 2. Equation number 2. Okay. Then we will take log again in equation number 1. So the process is same as it is for your case 1 or when we have using Sage's equation. Okay. Only the expression will be different because of the equation that we use for velocity. Okay. So again you take logarithm for the first equation. You will get this as our first equation is a r to the power 2 by 3 n. Okay. K equal to. So here again it will be log ek is equal to log e 1 by n plus log a plus 2 by 3 log e r. Okay. Then again we have to differentiate with respect to y. This will be n is again constant, it will be 0. Okay. Then it will be 1 by a. Again we have discussed this thing that area is a function of y. So that is why we have dA by dy. then plus 2 by 3, and ln of r, that is if we differentiate log er, it will be 1 by r. Okay? It will be 1 by r, and then r is again a function of y, as a function of y. So it will be again dr by dy. Okay? Here in place of r, we have directly substitute a by b. Okay, to reduce the steps. Okay, next line will be 1 by a c dA by dy. We have already discussed. We can write in place of dA by dy as top width. Okay, so that is why top width by area plus twice by 3r. Again, in similar way, we can differentiate a by p, that is u by v formula. Okay, that we have already discussed. Or you can also use u into v. So you can write down this expression. Okay. So again, the next line d by a will be there 2 by 3r. So r is again you can write a by p multiplied by with this dA by dy, again we can write top with, so d by p. Okay. So again this again we have to multiply with this term 2 by 3 r, again we write a by p. We have already a here and p square dp by dy. Okay. D by a will be there then twice t, this p and this p will cancel out. Okay, so 2t by 3a minus 2 by 3 is there. This area will cancel out. This p and square will be cancel out. So it will be 1 by p. So you can write 2 by 3p. This area is also cancel out. Okay, 2 by 3p dp by dy. Okay, then you add this to, you will get 5t by 3a minus 2 by 3p dp by dy. Okay, now we can equate equation 1 and 2. Okay, in equation 1, sorry, equation 2 and 3. In equation 2 is nothing but your log e k is equal to n by twice y. Okay, that is your equation number 2. And you can see equation 2 and 3, our left hand side is same. Left hand side is same. So that is why we can equate equation 2 and equation 3. It will be n by twice y, 5t by 3a minus 2 by 3p dp by dy. Okay. The next line will be your n is equal to, this will be multiplied here 10y t by 3a, then this will be multiplied with this also. So those are 4, 4 by 3, y by p. Again we have taken this a by p here, dp by dy, just to bring r. Okay. Finally, you can bring out twice y and 3a. What will be left out is 5t minus twice r dp by dy. So again, this is our general expression for hydraulic exponent in uniform flow using Manning's equation. Manning's equation. Similarly, you can also get the expression for trapezoidal channel, rectangular, white rectangular, or triangular. Okay. So there is a small topic left out. We will discuss in the next class, and then we move on to our next unit. Okay. This unit is almost over. There is a small topic we will discuss in the next class, and then we move on to our next unit, that is our canal design or channel design. Okay.